All right, so before we look at binomial expansion, we're going to look at a tool which is going to be useful for us to do some of these expansions. So some of you may have heard of it before, Pascal's triangle. All right, now, if I consider a starting point, 1, and I'm going to move my way down. So if I want to move to this position here, there's one path for me to get here. And if I wanted to move a position here, there would also be one path for me to get there. So from here to here and there to there. Now, so this first row, there's one component. The second row, there's 2. The third row, there's going to be 3 and so on. So in this third row, if I was to wanting to move in between these two ones, right, there's 2 ways to get here. I could come here and then down here, or I could come here and then across here. So imagine I'm linking them up with imaginary lines. So kind of like the paths that we looked at the beginning of the topic. Or if I was to continue coming down the triangle, here there would be one way to get there. So I could only get to there through here, right? And then if I'm coming down this way, I can only get there by going there, all right? So you can just imagine that there's little links in between these. So from here to here, there was one way. From there to there, there's one way. From there to there, there's only one way. However, that middle one, I could come through there, or I could come through there. Can you see? And then if I wanted to get to that one, I could only go there. All right, now, there's going to be 4 numbers in the next row. So if I was to continue down that path there, there's going to be a 1, because again, the only path that I can use to get to that point is down there. Now, in between this 1 and the 2, consider I can come down this way, so that's a path, but then I could also come down this way, which is a path, or I could also come down that way. So how many possible ways can I get to that position? 3. Okay, so there's a 3 here. Can you see that? And then similarly for the next one, so this position here, I could come down through here, that's one path, or I could come this way, that's 2 paths, or I could come down that way, and that would be 3 paths. Okay, if I was to come down there or there. And then finally, if I was just to go down that right stem there, then there would be only one way that I could get to that. Now, you can continue that process all the way through. So in the 5th row, there's going to be 5 components. So again, there's going to be a 1, then there's going to be a 4, and there's going to be a 6, then a 4, then a 1. Okay, and I went through the same process. And basically, you can consider, okay, well, to get to this point here, there was 3 possible paths. There was a path there, so to get to that point, there's going to be 4 paths. Okay, or for this 6 here, to get to there was 3 possible paths, and there was 6 possible, here there's 3 possible paths, there's 3 possible paths, so to get there, there's going to be 6 possible paths. Okay, so, and then you can continue to work your way down. So then I'm going to have a 1, a 5, and you can just see, look, that's a 4 and a 6, so how many paths would there be to get in between those? 10. All right, and then again the 4 and the 6, so there'd be 10. And then the 4 and the 1, so there'd be 5. And then down here, there's just the 1. Okay, I'm going to continue going down a couple more rows. So here it's going to be 1, 6, 15, 20, because there's 10 and 10. Then 10 and 5 is going to give me 15. 5 and 1 is going to give me 6, and then that's just going to be 1. Okay, then can we see how we're doing this? So then the next row, that's going to be a 1. Between the 1 and the 6 is going to be a 7. Then between the 6 and the 15, there's going to be 21, and so on. So this will be 35. This will be 35. This will be 21. This will be 7, and this will be 1. And we'll go one more row. So again, 1, 8, 28. What's that going to be? 56. Then 70. Then 56. Then 28. Then 8. Then 1. You might be thinking, well, how is this connected to anything that we've just been doing? So let's consider how this is related to combinations. So Pascal's triangle and its connection to or with combinations. All right, now I'm going to start at the top. So we know at the top of Pascal's triangle we have 1. Now, if I consider the second row, I'm going to get a 1 and a 1 again. Now, I just want you to consider, so with a combination, right, if I was to consider the combination of 1, 2, 0, and we practiced that combination the other day, we know that 1, 2, 0 would give me 1. Now, if I consider here the combination of 1, choose 1, that will also give me 1. Okay, now I'm going to move down to the next column, or the next row, sorry. So if I have a 1 here, because there's still one path, like we said, this middle one there's a 2, and then this one out here it's a 1. Now, I'm going to consider the combination of 2, 0, because 2, 2, 0 gives me 1. Now, if I consider combination of 2, choose 1, I get 2. And then if I consider the combination of 2, choose 2, I get 1. Can you see the pattern that's forming? Okay, the first number is related to the row that we're in, and then the bottom number is relating to which position we're in. Okay, so then if we go to the next one, and I put a 1 here, and then remember in between here there'd be a 3, in between those two there'd be a 3, and then there'd be a 1 over here. Okay, so let's consider the combination. We're now in the, which row? We're going to be, so you call that the 0th row, first row, second row, this is the third row. Okay, so this is going to be 3, choose what? 0. And guess what? 3, choose 0 gives you 1. And then if I was to do 3, choose 1, I would get 3. And if I was to do 3, choose 2, I would also get 3. And you can go and check these if you'd like. Or if I wanted to do if I wanted to do this one, it would be 3, choose 3. So you can probably start to see that whichever row that we're in, we would be able to work out what the value is. So if I was in the, say, 10th row, and I wanted to know what the third element was, then I would go 9, choose 3. All right, let's just do 2 more rows. So if I go 1, 4, and you can check these numbers from up here, 6, 4, 1. So this is going to be 4, choose 0. This is going to be 4, choose 1. This is going to be 4, choose 2. 4, choose 3. 4, choose 4. Okay, and last row, if I go 1, this is going to be 5, this will be 10, this will be 10, this will be 5, this will be 1. Okay, we're now going to be 5, choose 0, 5, choose 1, 5, choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. So how is this related to binomial expansion? All right, now, we've all learnt how to expand something like this. A plus b to the power of 2. And please don't tell me that a plus b to the power of 2 is a squared plus b squared. All right, there's also the 2ab that you need to consider. Yeah, so let's consider what this would look like. We would know, so we know that this here, if we expanded it, could be written as a squared plus 2ab plus b squared. Agreed? We've all done those expansions before. All right, now let's think about it. Let's try and apply a bit of a pattern to this. So if I wanted to expand a plus b all squared. All right, now this can be, just bear with me for a second. So if I was to write 1 a squared b to the power of 0, and then I was to add 2 a to the power of 1 b to the power of 1 plus 1 a to the power of 0 b to the power of 2. All right, so in here I had a and b, so that's why I've got a and b in each of these terms. Now what's happening to the power of a as we move through these terms? It was a squared, and then it was a to the power of 1, and then it was a to the power of 0. And then here it was b to the power of 0, b to the power of 1, and b to the power of 2. Now look at the coefficients. The coefficient of that term is 1. The coefficient of this term is 2. The coefficient of this term is 1. Can you see that that looks like the same as that? Okay, so, and then look at this. So this here, that term there, b to the power of 0 is just 1. B to the power of anything, 0 is always, anything to the power of 0 is always 1. So that there is going to give a squared plus 2ab plus b squared. Can you see how that is connected to that? See how it's the same? All right, what about if I did, what if I did this one? What if I did, so that can be a. What if I had x minus 2 to the power of 3? Now, this type of expansion isn't as easy because we'd have to break this up into, say, x minus 2 times x minus 2 to the power of 2. And then we could probably work through it that way. We could do some multiplications. It would be a long process, but we could get there. All right, so let's use Pascal's triangle to help us. All right, and let's use the same pattern that we just spoke about. So remember, the first term I had decreasing powers, and then the second term I had increasing powers, and then the coefficients were given using Pascal's triangle. Now, this first, if we come back to here, this first row we use for linear, if we're dealing with linear expansion. This row here we use if we're doing a quadratic. So the one that we just did was a quadratic. Now this row here we're going to use for a cubic. So if it's to the power of 3, and then this row here we're going to use for a quartic, and so on. All right, so here I've got something to the power of 3, so it's a cubic. So the row of Pascal's triangle that I'm going to use for the coefficients is this, 1, 3, 3, 1. Okay, so let's come back. Let's consider the first term. So the coefficient of the first term, according to what I've just said using Pascal's triangle, is going to be 1. Then I consider my first term, which is x. And now this time it's raised to the power of 3, not to the power of 2. So the power of the x is going to be 3. Then I've got this minus 2. This is going to be minus 2 to the power of 0. Because remember, the first term we're going to count down with the powers. The second term we're going to count up. All right, so then we look at Pascal's triangle. The next coefficient is going to be a 3. Okay, so now it's going to be plus 3. Now the first term, which is x, is going to be raised to the power of 2 because we're decreasing those powers for the first term. And then for the second term, we're going to increase the power by 1. Okay, and then the coefficient of the third term using Pascal's triangle again is going to be a 3. So it's going to be 3x, which was our first term, raised to the power of 3. And then the second term, which was minus 2, we're going to raise to the power of 2. Can you see how the second term is counting up, the first term is counting down with the powers? And then our last one, come back to Pascal's triangle, it's a 1. So we've got plus 1. Did I make a mistake? Sorry, that's meant to be a 1. I'm counting down with the first term. Okay, so it's going to be 1, x to the power of 0, and then minus 2 to the power of 3. All right, my apologies for that one. So you're counting down the powers with the first term, you're counting up the powers with the second term. All right, now let's simplify. So minus 2 to the power of 0 is 1. Anything to the power of 0 is always 1. So what's that first term simplified to? X cubed. All right, because this is minus 2 to the power of 0. So minus 2 to the power of 0 is positive 1, not negative 1. Okay, so that's going to be x cubed. Then let's have a look at this. Minus 2 to the power of 1 is minus 2. So it's going to be minus 2 times 3, which is minus 6, by x squared. So minus 6x squared. Then the next term, minus 2 all raised to the power of 2. Minus 2 squared is positive 4, times 3 is going to be positive 12 by x. So it's going to be plus 12x. And then this x to the power of 0 is 1. Anything to the power of 0 is always 1. Times, this is minus 2 to the power of 3, which is 8. But it's going to be negative 8, because it's minus 2 times minus 2 times minus 2. So this is going to be minus 8.